Okay, this is the solution to problem set 11.2, question number 37. So let's read through this real quickly. Okay. Now, I have an interesting story about this. When I was in West Africa, they used to cool the water in these big ceramic jugs. I mean, they're about knee-high and probably held 20 or 30 gallons. And they were clay, and the water kind of seeped out of the clay, and as it seeped through the clay got wet on the outside, and then that evaporated. And it was so hot, as the water evaporates on the outside, well, think about this for a second. Water has to evaporate. It has to take the heat from somewhere, and it takes it from the water that's inside the tub. And so the water inside got cooler because of the evaporative process. So remember that evaporation is an endothermic process. It needs energy to happen. So this question is, how many grams of water can be cooled by the evaporation of 60 grams of water? Okay, so here's the information here. I'll have to move this back and forth, but let's just start with understanding that there's two things that are going on. So this is question number 37. Okay, so first of all, we have the water that is evaporating, okay, and that is an endothermic process, and then we have the water that's inside the jug is cooling down. Now you have to understand that these two things are separate, so we have to basically break it into two problems. The water evaporating for the first part, and the water cooling down. Okay, so what are the formulas here? Delta H equals, when something evaporates, it's the mass of the amount that's evaporating times what we call HVAP. And HVAP is a constant, and actually I should probably call this Q just to keep everything straight. So we'll call this Q equals the mass of the water that's evaporating times the vapor constant. Now here's the vapor constant right here. It's 2.4 kilojoules per gram. See it here? The heat of vaporization of water. That's HVAP, 2.4 kilojoules per gram. So this becomes 2.4 kilojoules per gram. The mass of the water that's evaporating is 60 grams. 60 grams of your water is evaporating, so that becomes 60 grams. You can see then that the grams are going to cancel, and so we get that the amount of energy from the water evaporating, how much energy does it have to take away, is 60 times 2.4. 144. So that's 144 kilojoules. Now I'm going to do one thing right here to remember that this over here is going to be in joules, so I'm going to just convert this to joules right now. That's 140.000 joules. Okay? Okay, the water cooling down. Well, what's the formula for that? Well, that's Q equals MC, change in temperature. So when water cools down, we have to account for the change in temperature. Let's read the question. The temperature changes by 15 degrees. So this is 15 degrees Celsius. The specific heat of water, remember, is 4.18. And how much water? Oh, that's what we're solving for. So this equals M. This is the Q that goes here. So now we have 1.44 times 10 to the 5th joules equals the mass times 4.18 times the change in temperature, which is 15 degrees Celsius. Okay, so we're dividing both sides by that, and we get times 1,000. Okay, so there's the energy in joules divided by 4.18 divided by 15, the change in temperature, and voila, we have the mass is equal to 2296.65 what? What are the units? Grams of H2O. And finally, we will convert that to significant figures. From our significant figures, we see we have 2 here, 2, 2. Looks like 2 all the way through. So the mass of the water that can be cooled is 2.3 kilograms of water. And that is how that kind of a problem has worked. Thank you.